My name is Colin Brooks. I am a research scientist with the Michigan Tech Research Institute in Ann Arbor, Michigan, part of Michigan Tech University. And what this project is about improving our assessment of the unpaved road infrastructure, which is a critical part of our transportation system. And it's one that doesn't necessarily get a lot of attention, but it is an important part of getting both people and materials around. I mean, urban counties such as Oakland County, Michigan came to us and estimated they had about 800 miles of unpaved road, but no easy way to assess what their condition was, short of sending somebody around with a truck. So we came to the U.S. Department of Transportation Research and Innovative Technology Administration and said, we have a way of both mapping the locations of unpaved roads and of efficiently assessing their condition. And we can make this a practical, deployable tool for state and local transportation agencies to be able to use. And this poster focuses on the first half of the project, because we've just finished up the first year of the two-year study, and it's in taking commonly available aerial photography and being able to extract out where are the unsurfaced roads, where are the unpaved roads. And this might seem like a solved problem, but it isn't, because the typical road network at a state level or county level does not tell you whether it's a paved road or unpaved. And those have very different asset management solutions in terms of fixing the problems and when you need to fix the problem. So we have this color infrared aerial photography, what we would call 4-band near infrared imagery. So it has three visible bands, red, green, and blue in near infrared. And we can use that data and extract out the most important information and run it through some semi-automated processing software called Trimble Cognition. And we can start extracting out where are the unpaved roads from the paved roads. And we try to use a very rigorous methodology in order to make sure that our algorithm is performing well. For example, in making sure we use functionality such as receiver operating curves in order to pick parts of the algorithm that give us the best and most efficient performance. And you get some very different results, which make this make this an interesting issue. If you're in a farm area with no trees by the road, those are relatively easy to pick out, say a concrete or asphalt road versus an unpaved gravel road. However, in southeast Michigan, you've got lots of trees over roads, and even if you have leaf-off imagery like this, the trees and shadows can overshadow it, and you can make the road hard to detect. So there we've come up with a rule set that says, if you add on your road network to this and a certain percentage of a road segment is unpaved, then you can call the entire segment. So you don't have to be able to map every single line of it. And so here, this is Oakland County, Michigan, and this is about 2/3 done. The county told us they thought they had about 800 miles of unpaved roads, without even the entire county done, and the unpaved roads are in red on here. We found 1,100 miles already, and we're getting about 85% accuracy just with the current version of the algorithm. So where are we taking it from here? This becomes part of the mission planning system in order to be able to fly our sensor, which is using a high-resolution 36 megapixel digital SLR camera. And we're going to fly the sensor down roads for rapid deployment, including after, for example, major storm events, and be able to assess the condition and take those photographs and turn it into three-dimensional information that tells you the size of the rut, the size of the pothole, the amount of washboarding, the amount of loss of crown. And because we like to push the envelope in terms of research, we like to do the applied research side of us. We're not only designing a sensor that can be deployed in a typical manned fixed-wing aircraft, but we're also deploying one that can be done in an unmanned aerial vehicle or a UAV. So the same sensor can be deployed in different environments. Perhaps you can't rapidly get an airplane up, but you can fly your unmanned helicopter down several miles of road after a major flooding event to see what their condition and serviceability is, which is an issue in much of the U.S. So the UAV could be more practical to deploy. And the FAA is looking at revising small UAV regulations so this will be easier to deploy and currently operate under the FAA's research exemption, which allows us to test this out. So this is where this is the next phase, essentially the second year of the research, is to take the imagery, derive the 3D information, and deploy it both in an airplane and in an unmanned aerial vehicle. And we expect to be done in the latter part of 2013 and start sharing this with the larger groups of departments of transportation.